approximately 500 million years ago, Earth was vastly different from what we know it as today. At that time, there existed a single immense supercontinent known as Gondwana. The formation of Gondwana was a result of various geographical events occurring throughout Earth's history. These events caused the land masses on the planet to come together, creating this colossal supercontinent. Gondwana played a crucial role in the evolution and development of the Earth's geological structures, climate, and ecosystems. Eventually, through millions of years of tectonic shifts and various natural processes, Gondwana began to break apart into the continents we are familiar with today. These changes continue to shape our planet's intricate and ever-changing landscape, and become Antarctica, Africa, Australia, India, South America, and Madagascar. The formation of Gondwana was critical in the Earth's history, drastically influencing the development of life and ecosystems. As time progressed, approximately 108 million years ago, Gondwana started to fragment, gradually giving rise to the separate continents we recognize today. This breakup was brought about by various geological processes, such as plate tectonics and volcanic activity. The fragments of this once massive continent drifted away from each other and eventually settled into their present positions. During the early Paleogene period, which occurred around 66 to 23 million years ago, Antarctica maintained its connections to South America, as well as southeastern Australia. The remnants of ancient bonds between these continents can still be seen today in the shared geology and fossil records found in each location. Over time, however, these land connections weakened and eventually broke apart due to ongoing geological processes such as continental drift and glaciation events. The history of Earth's continents is a complex tale of formation, fragmentation, and constant change, driven by powerful geological forces. The of Gondwana exemplifies this journey through time and serves as a testament to the ever-evolving nature of our planet's landscape. And 53 million years ago, the separation of Australia-New Guinea from Antarctica led to the opening of the Tasmanian Passage. Around 30 million years ago, the Drake Passage opened between Antarctica and South America, resulting in the creation of the Antarctic Circumpolar Current that completely isolated the continent. The modern form of Antarctica emerged around 34 million years ago, when it was enveloped by a massive ice sheet. The distinctive geography and climate of Antarctica are essential in regulating Earth's climate. The Antarctic ice sheet spans an area larger than the United States and Mexico combined. Its white surface acts as a colossal reflector, reflecting heat back into space, thereby maintaining the planet's cool temperatures. Additionally, Antarctic ice significantly contributes to Earth's climate regulation by generating dense, heavy water that propels deep global ocean currents. Dinosaurs lived in Antarctica during the Cretaceous Period, which lasted from 145 to 66 million years ago. Antarctica was ice-free during this period, and the continent was covered in forests. The northern tip of the Antarctic Peninsula is well known for its dinosaur fossils, although few have been described formally. The dinosaurs that lived in Antarctica include ankylosaurs, the armored dinosaurs, mosasaurs, and plesiosaurs, both marine reptilian groups. Fossils of these dinosaurs have been found in several sites near the Beardmore and Shackleton glaciers. In 1990-91, scientists made the first discoveries of dinosaur fossils in the central Transantarctic Mountains of Antarctica. A site on Mount Kirkpatrick, near the Beardmore Glacier, yielded the bones of Crioliphosaurus elioti, a species wholly new to science. Alongside this specimen were the bones of a pterosaur, flying reptile, a tritylodont, mammal-like reptile, and another dinosaur later recognized as the new species Gladiolosaurus hammeri. All proved to be unique to Antarctica, evidence that by this point in time, barriers were preventing populations from exchanging genes across Pangaea, and today Antarctica species. Antarctica, though characterized by its extreme weather conditions and inhospitable environment, is home to a surprisingly diverse range of species. However, it is important to note that the overall number of species found in Antarctica is relatively low compared to other regions on Earth. The resilience of Antarctic wildlife is truly remarkable, as they have adapted to the harsh climate, which includes dryness, frigid temperatures, and high exposure. Among the species that inhabit Antarctica are 8 species of penguins who predominantly dwell on the milder shores of the peninsula and the subantarctic islands. Sharing their habitat with penguins are 7 species of pinnipeds such as seals and sea lions. The southern ocean surrounding Antarctica also serves as a sanctuary for 10 cetaceans, many of which are migratory. Approximately 200 fish species can be found in Antarctic waters, constituting 60% of the global seal population. One small but vital constituent of this ecosystem is the Antarctic krill. Despite measuring a mere 6 centimeters in length, krill play an essential role within the food chain. Forming groups in the thousands, they clean up the sea by feeding on phytoplankton, algae, and diatoms. Serving as sustenance for larger animals like whales, seals, and birds, these tiny creatures support the broader Antarctic population itself, but also have far-reaching effects on the Earth as a whole. One significant issue is the accelerated melting of ice sheets and glaciers due to climate change. As global temperatures continue to rise, the vast ice sheets of Antarctica are melting at a faster rate than they can be replenished. This increased rate of ice loss contributes to rising sea levels, which can lead to devastating coastal flooding, erosion, and loss of habitats for numerous wildlife species worldwide. Another related issue is the potential collapse of major ice shelves as they become increasingly destabilized by warming waters and melting ice. The collapse of these ice shelves would accelerate the flow of glaciers into the ocean, further exacerbating sea level rise and posing significant challenges for human populations living along coastlines. Additionally, Antarctica's unique and delicate ecosystem is at risk due to shifting climate conditions and increasing human activity in the region. Global warming leads to changes in precipitation patterns and temperature fluctuations, altering the habitats of native species such as penguins, seals, and krill. Furthermore, increased human presence in Antarctica for tourism or scientific, these challenges not only have severe consequences for Antarctica's environment, but also pose significant risks to global ecosystems and human populations worldwide. How will be future steer if it's not stable? Future solutions to save Antarctica revolve around a comprehensive approach that addresses various environmental challenges. This includes reducing greenhouse gas emissions, implementing sustainable practices in tourism and research activities, and enforcing international agreements focused on preserving the fragile Antarctic ecosystem. Climate change is the primary threat to Antarctica, so reducing global greenhouse gas emissions must be a top priority. The global community should work together to embrace alternative energy sources and increase energy efficiency in order to slow down the process of global warming. By mitigating climate change, we can help preserve the ice shelves and unique habitats found in Antarctica. Tourism and research activities also impact the Antarctic environment. To minimize their effects, sustainable practices such as strict waste management and responsible travel should be adopted. This would entail recycling materials, minimizing waste disposal, and using eco-friendly equipment when conducting scientific research or engaging in tourist activities. In addition to these measures, international agreements play an essential role in preserving Antarctica. Robust enforcement of existing agreements like the Antarctica Treaty System and the Protocol on Environmental Protection should be maintained by all parties involved, ensuring that human activity remains respectful of wildlife and natural resources in this pristine region. By taking a multifaceted approach, we can develop effective solutions to safeguard Antarctica's unique ecosystem for future generations, while addressing pressing environmental concerns that threaten its delicate balance. Thanks for watching video. If you like our video, then you can subscribe to our channel for more amazing relates video.